Hello everyone and welcome to the fifth tutorial of Applied Probability. We'll be going over continuous random variables, some particular distributions, and some general functions of a continuous random variable. So let's just get started. So the first question says the time until the next car accident for a particular driver is exponentially distributed with a mean of 200 days. So we know that if x is the time until the next car accident, then x is exponentially distributed with a mean of 200 days, which means that lambda is equal to 1 over 200, which just means that our PDF looks like this: lambda times e to the minus lambda x. Okay. Calculate the probability that the driver has no accidents in the next 365 days, but then has at least one accident in the 365-day period that follows this initial 365-day period. What's this asking for? It's asking for, so our random variable tells us the time until the next car accident. So the event we're looking for is the next car accident in our random variable. We want the probability that the driver has no accidents in the next 365 days, but then has at least one in the 365-day period that follows that initial period. So the desired event is equivalent to the time of the next accident being between 365 and 730 days from now. So let's look at the, this would help us, the cumulative probability function. For an exponential random variable, this is just equal to 1 minus e to the minus lambda x. And in our example, this just implies this 1 minus e to the minus 1 over 200 x. And we want the event that the accident is between the 365 and the 730-day period from now. So we're just looking for the cumulative probability of 730 days from now covers all of the days from 0 to 730. But we want to subtract the first 365 days. So we can subtract the cumulative probability for the first 365 days from this. And this gives us the relevant time interval that we're looking for. If we plug it into the formula above, to the equation above, we get 730 over 200, all of this minus e to the minus 365 over 200. If we calculate this, it comes out to be 0.1352. Let's have a look at this for a second and see if it's clear for you. All right, so let's just move on to the next question. Go over the question, try to solve it yourself. I'll just give you a minute and then we can go through it. Okay, so the loss due to a fire in a commercial building is modeled by a random variable x with density function given as f of x is equal to 0.005 times 20 minus x for the values that x takes between 0 and 20, and otherwise it's just 0. Given that a fire loss exceeds 8, calculate the probability that it exceeds 16. So we want the probability that x exceeds 16 given that x exceeds 8. It would make our lives easier to just calculate the complement of our CDF because we're looking for values of x exceeding some small x. So we can just find this. By keeping the lower limit as x and keeping the upper limit as the upper limit of a random variable. And if we integrate our function using these limits, we get the following expression. This is a pretty simple integral, so I'm not going to go over how it's being computed. And remember that here x is between 20 and 0. Therefore, we're looking for this probability and this conditional probability. Using first principles, we have the intersection. Let's just keep this as follows. Wait. Yeah. Divided by the condition that we're basing it on. Note that the intersection of probability that x is greater than 16 and x is greater than 8 is just x is greater than 16. If we're given that x is greater than 16 and we want to find the intersection with x is greater than 8, the intersection will only lie in the values which are greater than 16 for x. So this will just simplify to the following fraction. The probability of x is greater than 16 divided by the probability that x is greater than 8. Using our using this expression, this one, this is denoted as a survival function, by the way, for a random variable. So using our survival function, we can just compute the probabilities as follows. We know that 0.005 will just get canceled out, so no need to write that. Plus 200 minus 20 times 8 plus 8 squared over 2. This becomes 8 over 72, which is equal to 1 over 9 as our final answer. Let's go over the solution. You can pause the video if you want to. And let's just move on to the third question now. Since this is a recorded lecture, you can just email me or Sarah and we explain any of the solutions given if you have any confusions. So yeah, just keep that in mind. Go over this question for a minute and we'll solve it. Okay, so let x be a continuous random variable with density function f of x equals the absolute value of x divided by 10. And the random variable takes this value for x between -2 and 4. We want to find the expected value of x. We're given an absolute value of x in the function. So we'll have to split our integral into two parts. We know that x is negative for values between -2 and 0, and x is positive for values between 0 and 4. So we can just split our limits and split the integrals, sum it up. So what we're going to do is this, e of x equals the integral from -2 to 0, x times, so the absolute value would want to take the negative values of x in order to cancel out negative limits. So for the negative limits, we'll have x over 10, minus x over 10, ex plus 0 to 4, x times, now we have positive limits, so no need to add the negative sign, dx. Just to refresh your memory in case you've forgotten, for continuous random variables, we have e of x, sorry, this is a bit untidy. So we have e of x equals, this is in general for any continuous random variable. So yeah, let me just put this aside. And let's compute our integrals. This would just be minus x cubed over 30. And the limits are from -2 to 0. And on the other side, we have plus x cubed over 30. And the limits are from 0 to 4. We compute this and we get the expected value of x as 28 over 15. This is the final answer. Let's move on. Go through the question and just try to solve it on your own first. Okay, so a company has two electric generators. The time until failure for each generator follows an exponential distribution with mean 10. So X is the first generator. It's the time until failure for the, let me just write it down. Time until failure for the first generator. And Y equals time until failure for the second generator. Both these random variables follow an exponential distribution with mean 10. So we have X, Y, both follow an exponential with lambda equals 1 over 10. The company will begin using the second generator immediately after the first one fails. Calculate the variance of the total time that the generators produce electricity. So we have X and Y denote this, they denote the time until failure. We know that they're exponential. We want the variance. What's the variance of X? For exponential distribution, we know that the variance is always the square of the mean. And we also know that the mean is 10. So the variance of X equals 10 squared equals 100, which is also equal to the variance of Y because they're both exponentially distributed with the same mean. Now we can see from the question that both the generators are independent. Otherwise, so we're looking for a variance of X plus Y. Generally speaking, this is variance of X plus variance of Y. Was this minus or? I think it was. Let me just confirm. Okay, so variance of X plus variance of Y plus 2 times covariance of X and Y. But we know that X and Y are independent, so this just goes to 0. And then we just have 100 plus 100, and the variance of X plus Y is 200. So basically 2 exponential distributions with disjoint intervals are independent. And we know that the second generator will only begin after the first one fails, which is why we know that they're both independent. So let's move on to the fifth question. I'll give you a minute. Okay, so the question says two instruments are used to measure the height h of a tower. The error made by the less accurate instrument is normally distributed with mean 0 and standard deviation 0.0056h. The error made by the more accurate instrument is normally distributed with mean 0 and standard deviation 0.004h. The errors from the two instruments are independent of each other, so we know that there is independence between the two random variables. Calculate the probability that the average value of the two measurements is within 0.005h of the height of the tower. So let's define first x1. This is the measurement error of the less accurate instrument. And x2 is a measurement error of the more accurate instrument. We also know that, so let's say that the following denotes a normally distributed RV with mean 0 and not 0, with mean mu and standard dev sigma. Then x1 has a mean of 0 and standard deviation of 0.0056h, and x2 is also normally distributed with mean 0, but standard deviation is now 0.0044h. And they're independent. What do we want? We want the probability that the average value of the two instruments is within 0.005h of the height of the tower. Let's see what the average value looks like. That y, we want the average of the two random variables, right? We have two random variables. Let's sum them up. We want the average, divide them by 2. This just implies that the expected value of y, we know x1 and x2's expected values are 0. That would just also equal 0. And the variance of y equals 1/2 squared variance of x1 plus x2. 1/2 is being squared because that's the formula for any scalar being multiplied within the variance function. If you pull it out, you have to square it. There's a derivation available online. It's pretty simple, but if you have any confusion, you can always email us. So we also know that they're independent. So the sum of two independent normal random variables is also a random variable, which is why the variable defined as y is also a random variable. So y is normally distributed with mean 0 and standard deviation. So with the standard deviation, we take the under root of the variance, 1/4 times plus 0.0044 squared h squared. Remember, these are being squared because they're the variances. Above, we defined sigma as the standard deviation. So 0.0056h was the standard deviation. And we can't just sum standard deviations. We have to sum variances and then convert them to standard deviation. So which is why they themselves are being squared. And then there's a whole square root on the entire expression. And this just becomes 356 h. Like if you get rid of the square root and solve the brackets, etc., you get 0.00356h. And we want the probability that the average kya tha hamara, is within 0.005 h of the height of the tower. So this is what we want. Let's normalize this. So we will have, let me just write this below. We will have, what just happened? I'm sorry, one sec. Yeah. So we're gonna have minus so this is how we normalize or standardize a nominal variable in terms of z, so that we can use the z table. We subtract the mean from our value, which is just 0, and we divide it by the standard deviation. Okay. Notice that since the mean is 0, we'll just have two expressions in which h is being multiplied in the numerator and the denominator both. The h's get cancelled, and we'll just be left with the values of z between 1.4 and minus 1.4. We can calculate this as z less than or equal to 1.4 minus the complement of z less than or equal to 1.4. Due to symmetry, this is equivalent to less than or equal to minus 1.4. Using the table, we'll solve this and we'll get the final answer as 0.84. तो टेबल से हम देखेंगे 1.4 की values जो cumulative probabilities मिलती हैं. Just plug it in and calculate, and you should get 0.84. इसको zoom out कर लूं, have a look at the entire solution, see if it makes sense. Pause करके आराम से. Let's move on to the last question. So the sixth question says, let X and Y be the number of hours that a randomly selected person watches movies and sporting events, respectively, during a 3-month period. The following information is known about X and Y. E of X is 50, E of Y is 20, variance of X is 50, variance of Y is 30, and the covariance of X and Y is given as 10. The totals of hours that different individuals watch movies and sporting events during the 3-month period are mutually independent. So we have mutual independence. Some statistics are given regarding the averages and the variances. And now they say 100 people are randomly selected and observed for these 3 months. Let T be the total number of hours that these 100 people watch movies or sporting events during this 3-month period. So T is the number of hours that these 100 people watch movies or sporting events. And we want to approximate the value of T less than 7,100. The fact that it's asking for an approximation should hint towards the central limit theorem, since we have 100 individuals being selected. We're given statistics. We want to approximate it using the normal distribution. And we can go about that. Yeah, we can go about that by understanding that. All right, so we want the total hours, right? So we want the sum of X and Y. Let's define Z as X plus Y. This implies that the expected value of Z equals the expected value of X plus Y which is equal to the expected value of X plus the expected value of Y. And we get 70 for one individual. The variance of Z equals the variance of X plus Y. This just comes out to be variance of X plus variance of Y. That's 2 times covariance of X and Y. We're given all of this in the question, so we're just going to sum it up and get 90. Sorry, not 90. This is 50 plus 30. So this is 2 times 10. We should be getting 100. तो हमारे पास है कि the expected value of Z is 70. हमें ये भी पता है कि variance is 100. ये हमारे पास एक individual के लिए. अब central limit theorem से पता चलता है कि T is approximately normal. So we can say that T is normal would mean 100 times 70 or 7,000, and standard deviation or so standard deviation is under root of 100 times 100, which is equal to, so the inner term is equal to 10,000 and its square root should be 100, so the standard deviation itself is also 100. तो हमारे पास आ गया कि T is normally distributed with mean 7,000, variance 100. आगे काम आसान है, we just want T less than 7,100 की probability. This just becomes, अगर हम इसको standardize करें, for the z value, we subtract the mean, we divide by the variance, sorry, the standard deviation. Yeah, this should be 100 divided by 100. From the tables, we can see that this is equal to 0.8413 as the final answer. Have a look at the question, see if it makes sense. We're always available on email. You can just contact us there or ask on Piazza. And we'll try to respond as soon as we can. And yeah, I hope this helped. Best of luck for the quiz. See you guys in the next tutorial.